What comes into your mind when you think about climate change in our food systems? Let me guess, you're probably thinking about the impact on food production, weather patterns, planting, gardens, trees, and food production in general. And you're right. But did you know that food losses and waste also contribute to climate change? According to FAO, global food losses and waste contribute to about 8% of total anthropogenic greenhouse emissions. In fact, if food losses alone were to form a country, it would be the third largest global emitter. The situation is worse in Africa, which experiences food and post-harvesting losses that are sometimes upwards of 40% of the initial harvest. The problem is complex, but the solutions do not have to be as complicated. Solar drying is an ancient and effective means of reducing post-harvesting food losses that is applicable to Africa, where the weather allows for the same. Drying technologies can reduce moisture content in crops to the desired levels, reducing food and post-harvesting losses, while simultaneously reducing greenhouse emissions and combating climate change. To construct such structures, one needs proper contextual information, including the mass of produce to dry, initial and final moisture contents, wind speeds, temperatures, and solar radiation data. To make this work easier for you, we have developed an app that allows you to capture all this contextual information and to generate a well-informed engineering design that will ensure your solar dryers delivers as expected. Using the app is simple. Visit our website www.agriceng.cloud and go to the Apps tab. Select QING Innovation Track. Choose the type of crop you intend to dry. Next, type in your nearest location. Lastly, click on the Design Dryer option. The app will generate for you two designs, a simple one and an improved one. At the bottom of the page, select your most preferred option, and the app will generate a design report in the form of a PDF document. The report will give you the dimensions of your dryer, examples of similar dryers constructed elsewhere, design variations that you can adopt, and the engineering data required to complete the design. With the information, you can construct the structures, addressing food losses and combating climate change at the same time. To scale up, we have targeted tech-savvy African youth with tremendous potential to address the problems facing our generation. In our first rollout, we'll partner with the Bavosa, an organization under UNOP that supports the youth to construct solar dryers for their local communities. With the app, the youth will feed in basic information and the app will generate appropriate designs. Other organizations that we have reached out to include the Kenya Climate Innovation Center, the Climate Youth Association Network, and 8 Billion Trees. With their support, we hope to not just scale the app, but to also ensure it is sustainable. 8 Billion Trees, a carbon offset company, has already agreed to help us maneuver the carbon trading market, which we consider a possible source of finance to expand the scope of the app and to cover its maintenance costs. We are doing our part. Our challenge to you is, what are you doing to address climate change in our food systems?